In this video, I'm going to cover the concept of the law of cosines. And the law of cosines is one of the tools that we can use to solve for non-right triangles. So we have, here's the law of cosines, the law of cosines. And that it's basically the Pythagorean theorem where we have a squared plus b squared equals c squared. But it's this a, b, c configuration 2 times. So minus 2 AB cosine C. Now the only angle here in the law of cosines is this angle right here, C. And we know that because sine of an angle, cosine of an angle, tangent of an angle, the trigonometric ratios are always of an angle. And so these other variables here are lengths. We also have, besides the law of cosines, we could also use the law of sines. The law of sines to solve for a non-right triangle. And the law of sines is sine of angle A over length A. And that equals sine of angle B over length B. And that equals sine of angle C over length C. Now, I really think it's easier to just pretend that all of the non-right triangles that we could use the law of sines. I mean, if you don't know, if you're not told to solve by using the law of cosines, use the law of sines as a default. Now, if I use this particular problem using law of sines, well, let's set it up and see what it looks like. So I have sine of angle, well, 17 over, so I have sine of angle A over length A. Length A is always opposite angle A. So if I'm choosing this angle here, then the value that goes underneath sine of angle 17 is going to be x. And then we pick another angle. We'll say this angle here, which I don't know. We'll call it sine of angle B. We'll call this B. Then the length B is going to be opposite that. That would be 9. So I'll just write a 9 here. Now you can see I have an equation with 2 unknowns. Well, if I try to solve for those, there are infinite possibilities that will make this statement true. So this is why law of sines is going to fail me for this particular problem. And it's why law of sines is going to fail us for all of the problems. You can test yourself for each one of these if you want to. So we are going to be limited in this choice then, or as far as the choices between our tools, we're limited to the law of cosines. 1, this is a non-right triangle, so we're stuck with one of the 2 choices. And 2, law of sines fails us. So I'm going to just go ahead, because for the law of cosines, the only angle here is angle C. I'm going to label the only angle that I'm given here, I'm going to label that angle C. So, and then your A, so that would mean that my length C is going to be x, and the A and B are somewhat interchangeable, so it doesn't matter. So I'm just going to go ahead and start. I have 9 squared plus 14 squared minus 2 times 9 times 14 cosine of 17, that's my angle, and that equals my x squared. Now I can throw this whole line into my calculator because there's no variables in there, so that's what I'm going to do. So I have 9 squared plus 14 squared minus 2 times 9 times 14 cosine of my angle of 17, and that's going to give me 36.0. Let's stick with 3 significant digits. So 36.0. So x squared equals 36.0. Now I'm going to take the square root of both sides, and the square root of 36, well, that's just 6. 6 doesn't have units here, so we'll just say 6 units. X equals 6 units. Let's look at number 2. One suggestion that I have is that you could pause the video, try to do the problem yourself, and then when you push play, you can see whether I have the same answer that you were able to find by doing it independently. That's really how we learn, is by that struggle of trying to do the problem on our own. So in this case, here's my angle here. So I'm going to label that angle C, which means x again that is my length C. And we're just going to use the same equation again. I'll just write it down. It's really not that hard to remember. It's the Pythagorean theorem of a squared plus b squared equals c squared. But it's this ABC configuration 2 times, so negative 2ab cosine c. My only angle is here. The only angle is here. So I'm going to just plug that angle into here. And A and B again are interchangeable. So I have 12 squared plus 13 squared minus 2 times 12 times 13 cosine of C of 134. And that equals our opposite length, which is going to be x squared. Again, there's no variables in here. I'm just going to throw all that into my calculator. So that's going to give me 12 squared plus 13 squared minus 2 times 12 times 13 times cosine of our angle of 134. But that is going to equal x squared. So I'm just going to take the square root of that value, and that gives me 23.0, about 23. So I'm just going to write some of this information down before I change screens. So in my calculator, I found that x squared equaled 529.733. I took the square root of both sides. That gave me about 23.0 units. So x equals about 23. Now 3 and 4 are going to be a little bit more difficult because I'm trying to find an angle. And we usually denote an angle by using Greek symbols. This is theta, or we could use alpha, or we could use beta or phi, or really any of the Greek symbols. It's a great way of differentiating a length, a side length, where we use Latin letters A, B, C, D, or Greek letters to denote some angle or like rotation. In fact, an angle, that is a rotation, whereas a length, that's from a distance from one point to another. So I'm going to try to find this angle here. We could try to use law of sines. We're going to see again that we don't have enough angles. With law of sines, I'll have 2 missing angles, or here, it doesn't matter. So we're stuck using law of cosines. Law of cosines, again, is just the Pythagorean theorem of a squared plus b squared equals c squared. But this ABC 2 times, so negative 2 AB cosine c. The only angle I have is here, angle C, so I'm going to make that theta. This is going to be C, which means that length C, length C has to be the 21.9. And then the A and B, those are interchangeable. So I have 10.4 squared plus 18 squared minus 2 times 10.4 times 18. And then cosine of theta equals the opposite length of 21.9 squared. Now this gets a little bit tricky, so I'm going to at least solve for this part over here. I have 10.4 squared plus 18 squared. That's going to give me, I have 10 squared, 10.4, I apologize, 10.4 squared plus 18 squared. And that gives me 432, gives me 432.16. So this piece here, this 10.4 squared plus 18 squared becomes this 432.16. Then I have this minus. Let's figure out what this piece here is. So I'm going to throw that into my calculator. I have 2 times 10.4 times 18. And that's going to give me 374.4. So this piece here, this 2 times 10.4 times 18 became this 374.4. I still have this cosine theta here, and that equals this 21.9 squared. 21.9 squared. Oops, I did not mean to do that. Let's see if I can fix it. So 21.9 squared, and that gives us this 479.61. So this is what I have here so far. What should my next step be? Well, my next step is I should subtract this 432.16 from both sides, 432.16, and that gives me negative 374.4 cosine of theta, and that equals, well, it equals some number. We'll figure that what that is right now. So I have this number, and we're going to subtract it from the 432. That was this number here, and that gives us 47.45. So, well, now what? Well, this part here, this is times. So I'm going to divide both sides by this negative 374.4, negative 374.4, because negative 374.4 divided by 374.4, or negative 374.4, is going to give me 1. So that leaves me with cosine theta equals negative, well, something. So let's just go ahead and throw this into our calculator. So I have 47.45, and I'm going to divide it then by this. I'm going to divide that by our negative, well, this value here, and that's going to give us negative 0.126736. And I'm going to try to hold on to as many decimals as I can, because that's going to be relevant then, as far as I might end up with a rounding error. Next step, I'm going to take the inverse of cosine of both sides, so that's going to give me, so I have theta then. If I do the inverse of cosine on one side, then the cosine disappears, and I'm left with theta by itself equals the inverse of cosine of this value here of negative 0.126736. When I throw that into my calculator, then I have here's my tangent, my trig, inverse of cosine of this value, and we see that we get 97.28. So theta equals 97.3. Let's stick with 3 significant digits. All right, so what we're saying here then is that this angle right here, it is obtuse, it looks like it's obtuse, and we know now what this angle is. It is the 97.3. All right, let's move on to another one. If we look at this problem here, same concept. We're going to start here with this. We're trying to find this angle here, so we're going to label this angle C, and our equation is a squared plus b squared equals c squared, and it's this ABC configuration 2 times, so minus 2ab cosine c. And A and B again are, well, it doesn't really matter so much which one is which, because we're adding. I'll just throw in 11 squared plus 17 squared minus 2 times 11 times 17 cosine of our angle of alpha equals C. Well, this, if my angle C is here, then the length C has to be opposite. That would be the 10. So I have 10 squared. 10 squared, of course, gives me 100. And 11 squared, that's going to give me, is that 100, 121. And then 17 squared, I don't know what that is off the top of my head. So 17 times 17, that's going to give me 289. And then we also have to find out what 2 times 11 times 17 is. And that is 374. So 11 squared is 121, 17 squared is 289, and then minus the 374 cosine of our alpha. So we can combine like terms here, and so that's going to give us, well, 9, 10, we can carry 1, so, and then 8, 9, 10, and that gives me 3, does that give me 400? 410, I believe. 410 minus 374 cosine alpha equals 100. Now we're going to subtract the 410 from both sides, 410. That's going to give us this negative 374 cosine alpha equals negative 310. We now divide, this is multiplication, so the inverse of multiplication is divide. We're going to divide by negative 374 to both sides, negative 374. Negative 374 divided by negative 374 is going to give me 1. I have cosine of alpha equals, we'll just throw that in our calculator to get that we have the negative divided by a negative is going to give us a positive. So I have 310 divided by the 374. That gives us, well, I was hoping for a decimal, but it doesn't matter. So we get this 155 over the 187. And then we take the inverse of cosine to both sides. So I get alpha equals the inverse of cosine of this 155 over this 187. And that's going to equal, let's see, the trig, the inverse of cosine of this amount. It gives me 34. So I get that my angle, the angle here is 34 degrees. Right? Well, I hope that was helpful, and have a wonderful day.